set up. So just a second, I'm just waiting for all of the astronomers to arrive here. And there's Roy. Wow, you're strangely cut off.
Yes, I am. I'm square.
You're square. Don't be a square, man. I wonder why that is. That's really unusual.
Yeah.
So we're going to have Gary tonight. I think is the only person who's going to have clear seeing. So there's Gary. All right. I've gone live with this. So we're now live. And so hopefully people will navigate and find it. Let's switch to Gary's view. Hey, Gary.
Hey.
So we're now public and live, so
Good.
keep that in mind.
Okay.
Talk your salty astronomer talk. There could be children watching.
Oh yeah, possibly. Okay, that's framed pretty good. Okay, there's. I would like to start out with the old Orion.
Yeah. So what's your settings on this one?
I'm at 10-second exposure, and it's the hydrogen alpha filter. Okay, let me see.
So you know what's really cool about this now is if you want to watch a Hangout full screened, you can click on the, if anyone's watching this now, down at the bottom right, there's a little box. You can click that, and then you can get this full screened. So before, sort of the first 20 comments of every live stream event that we do is how can we get this full screened, and now it's possible. Oh, look at that! Wow.
That's at 50% resolution. I can get into that
Oh, wow.
area a
Wow.
little bit more. That's the full resolution of the camera.
That's the full resolution of the camera. Wow.
Yeah. So to get the whole thing on, I have to take it down to 25%.
It's that big.
Yeah, there's 50% right there.
Well, 50% looks really good.
Yeah, that's a good one.
Yeah. And so just sort of if anyone is now starting to watch, we've got the Orion Nebula here. Hey, there we go. There's some people watching. So we've got the Orion Nebula, and as imaged by Gary Gonella, and am I saying your name right? Is that right?
Yep.
Gonella? Yep.
Yep.
Gary Gonella, and he's got his 14-inch Celestron, which has the fast star setup where the camera is focused onto the Gary. We don't get to see your face, unfortunately. It's always a telescope.
Yeah.
Nameless, faceless Gary behind his telescope. So he's got this camera connected up to the front of the telescope as opposed to the back, and so what that lets him do is get a really wide field of view, and it's a very fast telescope, so he can get views of really dim objects in these light-polluted Los Angeles skies. And so what we're looking at right now is called the Orion Nebula. This is also known as M42, Messier Object 42. We actually did the Messier objects as this week's Astronomy Cast episode. So that was what we did. So what's the with M42? Is that the whole thing? Is there a different name for that little fellow over on the right?
I don't think so. There's one right here that they call the Running Man. I don't think I can pull that out at this exposure.
But you could pull it out at a different exposure. Could you slew a little to the right? Whoa!
Let's see it. It's
there it is. Oh yeah.
Yeah. Let me get a little bit longer exposure. Let me do a 1 minute.
Okay.
And we'll see how that looks.
It actually does look like a man running.
Mm-hmm. And then we've also got Roy Salisbury here, and Roy is another one of our astronomers, but he is far away from his observatory tonight, so he's here for color commentary.
And by the way, Roy, nice to meet you.
Oh, nice to meet you too.
You guys have met before. You just probably didn't realize it.
Yeah.
Roy's the one in Arizona. He's got the observatory in Arizona that he drives to from Las Vegas. He's got the 8-inch Celestron, and you've got another scope there too, right?
I have an 8-inch Celestron. I have a 106 millimeter Astrotech and a 66 millimeter.
Really cool. There we go. Jerry Rockamore wanted me to mention that the full screen selection is a little bit wonky. So if you don't see the full screen resolution, you probably want to refresh the live stream, and then you'll get the you should get it. You should see down at the bottom right. There's like a little square, and you can click that and then think. But it's really cool actually. It just instantly flashes to full screen, which is really nice. So the only problem with that is you don't get to see everyone's clever comments, but you should be able to just bounce back and forth, hit escape, look at the comments, etc., etc. So that's really cool. Oh, there you go. So according to Wikipedia, the Little Comet Nebula is M43. Is that right?
Yeah.
Is that M?
Okay.
Is M43 the Running Man, or M43 is the little?
I think it's probably that
43 is the Orion Nebula.
43 and then M42.
Yeah.
Or 42, yeah.
Right. So there you go. Okay, we can see the Running Man now. Can you slew to the side to get it more centered, or I don't know if people can see it on their on the live stream.
Let me see what.
And so Gary is located. You're in Ontario, California, right?
Correct.
Yeah. So he's really close to the Ontario airport, and so he has very light polluted skies. So to sort of crack through the light polluted skies, this is the telescope that he's got set up. Otherwise, you wouldn't see much for the dim objects. You would be able to see planetary stuff. I mean, you can see planetary stuff from almost anywhere, but for the really dim views, you need a telescope set up the way he's got it. Now, if you notice, we've got almost a full moon. It was a full moon last night, and so the full moon is washing out the sky. So we're definitely not having as clear a night tonight as we would have had it another night. And unfortunately, all of the other astronomers are clouded out. We might have Stuart Foreman joining us in a little bit, but other than that, it's been a pretty rough weather for everybody. We were actually just talking about this before we started the live stream, which is that I can't wait for summer because there's going to be a whole bunch of really wonderful objects. We're going to be able to get the Ring Nebula. We'll be able to get the great globular cluster in Hercules. We're going to be able to get... I'm trying to think what else would be really nice for the summer. But the problem is that we actually can't start until about 9 o'clock for various people because the days are longer, and so it's kind of ironic. I think you went the wrong way.
Yep. I'm coming back.
Okay. Yeah, so that's kind of the downside of this. And I've had a chance to test out with probably 3 or 4 telescopes just this week. And I got some really beautiful views, some really neat stuff. I have one guy who's got a really great full color. He had a Malin cam, which any astronomers out there who know it's a really nice sort of camera for planetary and astrophotography work. And did some tests with that, and it just looked beautiful. So we would see the Orion Nebula just like this, but in full color. And it actually did pull out the greens and the whites and the blues and stuff. And the other thing that looks really nice is seeing even star clusters. Seeing star clusters in full color, you really see the different colors of stars, the blues and the whites and the red stars that are all collected together. So
makes it look more 3D.
Yeah, the color makes a big difference. I mean, the thing is with what Gary's got set up, he's got all these, he's mentioned he's got the hydrogen alpha filter, he's got a sodium filter, he's got a bunch of different filters, an oxygen filter, and so you produce a color image by capturing everything with one filter, and then you use a different filter, and then a different filter, and then that creates the colors, and you get these, you pick one color is green, one is blue, and one is red, and then you get this really beautiful interplay of the colors and nuance, but it's not true color. That actually can kind of look a little different. So.
Okay, we're downloading the 1 minute here, so.
Okay, and so what we're doing, so with the different objects, when we're viewing something really bright like the moon or Jupiter or Saturn or Mars, we want to do live video, and then you get the, you get the object kind of wavering. You can see the atmospheric distortions that are happening. Whoa, what happened there?
I'm zoomed in.
Oh, there we go. Yeah, so there you go. And can you zoom in on that guy again?
Yeah.
So I don't know if people can see the Running Man shape of the nebula.
It's hard to see without the colors.
Yeah, it's more of a silhouette inside the nebula.
Cool.
Yeah, I think it's the head here and legs here. When you get the false color, it shows up real nice.
Well, the one that definitely works out great is the, oh, here we go. So you should just join us. So Teal, do you want to join us in the actual Hangout? Yes, we can. Oh, I don't know if I can. Okay. Because I don't have you in a circle, and I have to start it back up again. Okay. Okay, sorry, no one knows what I'm talking about. I was just reading the comments, and so Teal Bristra says, the Running Man Nebula is NGC 1973, 5, and 7. It's a reflection nebula, a half-degree northeast of the Orion Nebula, and the three objects are divided by darker regions. It's called the Running Man Nebula and the Sharpless Catalog 279. So there you go. Well, that's cool. All right, so we've got the Running Man Nebula. We've got M42, M43. Do you want to try the Horsehead? It's kind of close, right?
Yeah.
Okay. And this was a complete surprise to us. We did not expect that Gary would be able to provide these amazing images of the Horsehead Nebula so quickly and easily, and it's just amazing. So the nice thing about Gary's setup, I don't know, you want to show your telescope?
Okay.
He's got a camera. He's got a dome set up. Just sort of. Is it just connected to your house? Is it just out back?
Just out back, yeah.
Yep. And then he just has to align it once, and then calibrate it every now and then. But he can move the telescope around from the comfort of his house. So. This is really nice, and so we're hoping that we're going to be joined by another couple of telescopes soon. We hope. But
I didn't expect to have clear skies tonight.
yeah. So sometimes we've got to jump on it when we get the clear skies. And Pamela might join us. Definitely not Phil tonight.
That's too bad.
Yeah.
Okay, I got that one saved.
Oh, were you saving images of it?
Yeah, I was just saving them.
Yeah.
So we can put them up. I mean, they're not the best, but for a live thing, it's pretty good. Okay, we should be there. Let's take a quick preview. Okay, I'm going to do a quick 5-second exposure, and we'll see what she looks like.
So different objects, we like to use different amounts of exposure time. So that image that we were seeing there, you could see the Orion Nebula itself was a little overexposed. It was running about a minute-long exposure. So it's in there right now. So we're there, right?
Yeah, but I need a little more exposure.
Yeah,
Hang
clearly.
on. Let's do this.
You're going to bin it?
Yeah, I'm going to bin it and then do a 10-second and see what that looks like. Okay, there's a 10-second. So.
And this is where I think we'll get a chance to really compare really dark skies against really light polluted skies, because we had a really beautiful view of this just last week, right?
Which camera are you using again, Gary?
The
Oh.
QSI 583.
There it is. I guess you need to unbin it.
Unfortunately, they came out with a new one. This one takes about 30 seconds to download over USB. They've got a new model that downloads in a second. Always that's the way it goes, though.
Yeah. Can you return it? Oh, there it is.
Yeah.
Oh, look at that. So I hope people watching can see this.
I should probably connect on my other computer and see how it looks that way.
It looks phenomenal.
Looks great.
Yeah.
Okay, yeah. Even in a little window, it's not bad. So that's just a 10-second exposure, but it's a 4x4 bin. So you're seeing the picture at full resolution.
Oh.
What I can do is I can shorten this up a little bit so you see more of it.
Look at that. I mean, there is no question. I like how you've got you happen to have the rotation of the camera aligned so that you get the Horsehead is sort of
up. Yeah.
Up. Yeah.
These are one of those objects that's just perfect if you line your camera level.
Mm-hmm. Yeah, mine's aligned with the bottom of the scope.
Yeah.
And of course, it's backwards from what it looks like in the sky, but
yeah, and it's backwards from what you see in your view as well.
Yeah, that depends on
So in other words, so right now we're seeing the horse's snout go to the right of our screen. Right, but when you in the Hangout, you see a mirror version of what anyone else sees.
Oh, is that?
Yeah.
Okay, in the regular Hangout, on the Hangout I'm with you, I'm seeing it backwards. On the regular Hangout where I'm looking, it's to the right.
That's right. Yeah, exactly. Because in other words, so if you raised your right hand, you would see yourself raise your left hand, and so they need to make it. The Hangout needs to be a mirror, and so you don't get confused.
Yeah, I did that with the moon the other week. I made it so it looked right on my screen, and everybody else was confused.
Yeah.
Pam was going, what?
Yeah, exactly. So that's
I'm gonna see the IC2177 is up, which is the heart and soul.
The what? So let's see if is everyone done just gazing beautifully at this amazing image. I mean, that is phenomenal.
And that was a 10-second exposure.
That's a 10-second exposure.
10-second exposure.
Wow. Okay, can we try a longer one?
Sure.
Will it blow it out?
It'll blow the star out, but the rest of it should be good. Let's
That's amazing. That's only a 10-second exposure.
Well, it's also a bin 4x4, so it would have to be 160 seconds should give me the same amount of light if it wasn't binned.
Right.
Okay, we're doing a 1 minute, so...
So if anyone wants to know, this is also in the Orion Nebula, and we usually like to go to the Horsehead Nebula after we do the Orion Nebula because it's located really close in the constellation of Orion. It's just near the star Analtac. So if you go out to Orion and you look up at Orion, which is up right now for most people, and you look at the belt, the one that's the farthest east, so that's over on the left, usually it's like the left-hand side if you looked up, that's Alnitak, and the Horsehead Nebula is really close to it. And it's a dark nebula, so you're seeing like parts of it that are actually obscuring some of the light. It's really cool. All right. Okay. So where were you hoping to go next? Oh, you're changing the exposure time. This is a longer exposure?
Yeah, this is a 1 minute. Let me get a little contrast in there. Not enough. That's got quite a bit of contrast.
Yeah.
You can start seeing the wisps up at the top more.
Yeah. I love photographing this. And hydrogen alpha is good because most of this is hydrogen gas that's glowing in that form. And from what I understand, for anybody who's listening, this is pretty much the same across here, and then the Horsehead is a dark piece in front of it. So it's a dark cloud.
Yeah, that obscures the background.
And this is all, I think, getting lit up by Anatech. I think that's how you pronounce it. But you can see it's tough to get a dynamic range. It's tough to get a star and this. If I bring this all the way over here, so you can see the star's still blown out. And then I don't have the Horsehead.
Yeah. Phenomenal. Hold on a second. Pamela's going to join us so we can get some actual science happening here in a second.
Oh, cool. Somebody who knows what they're doing.
Yeah, exactly.
Let me just see if we can get anything out of this. I did some shots of it. Well, it should up. Yeah, it should be up. Let me try the 2177.
So sorry, you were going to go after, what was it, the heart and soul? What was that?
Yeah, the heart.
The heart?
And there's one next to it that's called the soul. I see 2177. And this is huge. I can see about a quarter of it in my view.
Oh, it's also called the Seagull Nebula, right.
Okay.
Yeah. Yeah, okay. I believe there's Pamela. Hey, Pamela.
Hey, hold on.
Recognize that?
What was that?
Do you recognize that on the screen?
That's the Horsehead Nebula in amazing resolution.
Isn't that phenomenal?
One sec, I need to switch where the sound's coming out.
So if anyone is wondering who this is Dr. Pamela Gay. This is my co-host on Astronomy Cast, and the person running CosmoQuest, which is a really cool astronomy. What do we call this? An astronomy education portal? It's an
astronomy. It's a community for people learning and doing astronomy.
Perfect. And
Hi,
you
Pamela.
actually, and so Pamela, we've got Gary and Roy here tonight.
Hi, Gary. Hi, Roy.
Hi.
And so you actually just came off of doing another live hangout, right?
I did. I paused long enough to scarf very spicy noodles, so I'm afraid I'm going to like set my microphone on fire.
Yeah.
But so as part of CosmoQuest, every Wednesday night if you're in North America, middle of the night if you're in Europe, early in the morning if you're in the Pacific and Asia, we're going to be doing astronomy hours. So this is going to be either roundtables of scientists or lectures, a whole variety of different things geared to recreate the seminar experience that you'd get if you were working at a normal science center. So the idea behind CosmoQuest is to basically recreate the environment of a science center, but do it virtually and do it in a completely open way so that anyone can be involved and be part of discovering our universe.
You're amazing.
No, I'm just filled with spicy noodles, that's all.
So Mark Langridge asked, when you guys are talking about binning the exposure, what do you mean? Even as a photographer, I'm not familiar with the term. Pamela, you want to cue up your what is binning?
I can actually, I need one more card to do this. Okay. You can't read the numbers on any of these. So normally you'd have a set of 2 by 2 pixels.
Well, let me switch to Pamela here.
Okay. So normally, and I'm going to try and hold these apart, you'd have a grid of 2 by 2 pixels. Now, each of these pixels is independently collecting light. Now, when you bin them 2 by 2, you say, I'm going to take these 2 rows, combine them. I'm going to take these 2 columns and combine them. And all the light from all 4 of those pixels gets combined into 1 pixel on your screen. Now, this means that you lose resolution, but it also means that you're able to combine all that light that was previously hitting all 4 different locations. And so you're able to much more quickly gather enough light that you are able to detect something with your detector. If you only see 2 or 3 photons, it sort of goes, I don't care. If you see 2 or 3 photons in each of those pixels and combine them into 12 pixels. Suddenly, your detector cares, and you get beautiful pictures.
There you go. So now you know. That's binning. You should have some kind of I don't know, some kind of visual aid for next time. So
yeah, I meant to. I just sort of got caught by surprise with this particular hangout.
Yeah, Phil would have a little image of the a little model of the galaxy that he could break out at any point. So there's Peter. Peter Lake has joined us. Hey, Peter.
Hi, Peter.
I don't think he can
Do you hear us, Peter?
Yeah, hi, Fraser.
Oh, there we go. So, Peter, we got Gary, we got Roy, we got Pamela. Now, you've got sunshine behind you and an exotic Australian accent, which makes it really, you know, how could you be joining us on this virtual star party? Oh, it's like a big delay, maybe.
Well, the signal does have to go transatlantic twice.
I guess it does, yeah.
Or trans-Pacific.
But Peter's got a automated telescope running out of Arizona, right, Peter? Oh, I don't know if you can hear us or we can hear him. Anyway, if we're lucky, he'll be able to display images from his telescope. I was hoping he would start with Venus, but I'm not sure what he's got in view right now. So Gary, you've got, so this is it. This is the Heart Nebula, is that right?
Yeah, the Heart, it's the IC2177.
Yeah, and that's the one I call the Seagull Nebula.
We're seeing about a third of it. If you talk it as a seagull, here would be the head, and the wing is like this.
Yeah.
And we're seeing a third to a quarter of it. It's really huge.
What constellation?
Oh, Canis Majoris?
Mon.
I'm looking.
Oh, okay.
M-O-N.
Yeah, it's a long, impronounceable constellation.
Okay.
It's the one that had that amazing nebula that went off in like 2002, 2003.
And this is, while we're on here, just for those looking, this is part of my learning experience. I had no clue the size of the stuff that was out there when I started doing this.
Uh-huh.
And that's why I've got the telescope that has the wide field of view, because I want to see this stuff. And I still can't. To get this, I'd have to take 4 to 6 shots and composite it together to get the whole thing.
The North American Nebula is just the same annoying way, and it's brilliant.
Yeah, I know. That's the one I first pointed at when I had the camera on my 8-inch scope at the back of the scope, so it was f10. And all I could see is just some fog. Yeah, I was seeing about 1% of the nebula.
The telescope that I used for most of my graduate school research, both my master's thesis and my PhD, was configured very much like yours, one that the light comes down, hits a mirror, goes up to the front, and the detector's at the front of the telescope. It was the 30-inch prime focus camera at McDonald Observatory. And it was amazing because it had the same glorious giant field of view. I don't think it was quite as big as yours. It was, I think, 63 arc minutes by 63 arc minutes, and you're bigger than that. But the thing that always got me was because I didn't have that many pixels comparatively, I had 2048 by 2048 pixels. If the sky got too crystal clear, I had to unfocus the telescope to prevent the stars from going square. And you must have the exact same problem with your stuff.
I haven't seen them go square, but yeah, if you get it just in 1 pixel. No, I haven't seen that. But yeah, I'm about a 60 by 90 arc minutes, so about a degree by a degree and a half.
How many pixels by how many pixels? I'm
3,000 by 2,000, a little over 2,400. I made megapixels, so 32 by 24, something like that.
Yeah, so unless you're at a perfect site, you're not going to get square stars. Being at McDonald Observatory, we sometimes got sub-arc second seeing, and that equaled square stars.
Ah, yes, yes, yes. And I can never anything sub-arc second I can't even think of. You know, from what I've done and from what I've studied on it, in an amateur situation, if I get 2 arc seconds per pixel, I'm doing great.
Yeah.
And that's, when I chose this whole thing, I have 1.5 arc seconds per pixel as my setup.
So,
And
so for
knowing-
all of you who are doing what is this arc second thing of which you speak, if you take one piece of hair and you hold it at arm's length, and my hair is almost long enough to do that without pulling it out, but I'm not going to pull it out, and you hold it out at arm's length, the width of your hair at arm's length is 1 arc second. And when we measure the separation between things, we do it in degrees, we do it in, and then we follow the same thing that you learned in 7th grade math, degrees, minutes, seconds. And so your fist on the sky at arm's length is 10 degrees, and then you can work your way down. The moon is about half a degree across on the sky, so half a degree, that's 30 minutes. Each one of those minutes is 60 seconds. And about the best you can get without putting technology like adaptive optics or something involved is a little bit less than 1 arc second of seeing for the most perfect skies on the planet. And reality is more often you'll get no better than 3 hairs, 3 arc seconds on the sky in most locations.
Okay, and that's how I calculated if I could never see anything smaller than 2,
Yeah.
then having 1 being a pixel on my camera gave me the best field of view without losing too much. Okay, I
You did
am
just fine.
now popping it over to Andromeda, since everybody seems to like that. We'll put it on there. And if anybody's got any requests.
Any requests? It's like a radio station or something. How is your? How are you doing, Peter? Can you hear me yet? No, I don't think you can hear me. Or see my chats. So.
Yeah, I can hear you now, Fraser. Sorry about that
Okay.
before. Just took a little while for the bandwidth to sync up across the Pacific, I think. Sounded very choppy.
Yeah. Are you? And have you got your telescope rolling?
Yeah. While Gary's slewing there, we might just show you what my all sky camera looks like at the moment. So.
Okay, let me see if
So
I can...
it's a little bit cloudy in New Mexico at the moment. So.
Right. So, and this is what I
fabulous.
was getting at, which is that you're located in Australia, but you've actually got a robotic telescope that's located in New Mexico, which is viewing. And so this view we're seeing right now is your all sky, which is amazing. And what are those sort of blobs over on the side of it? Are those other domes?
They're the domes, out there. So they're the dome telescopes. There are a number that are in another shed with a slide-off roof. But yeah, there's some domes there. And as you can see, the moon's just starting to rise in New Mexico, so it's highlighting that cloud. I think Orion's just in there somewhere, and you've got Venus and Jupiter setting in the west.
Right. So for people to see sort of that on the I guess it's the left-hand side of this image, it's sort of, you can see the moon. It's totally sort of washed out, and then over on the right-hand side you can see 2 really bright stars, but those are actually Venus and Jupiter. That is really cool. So I see Venus is really close to the horizon for you. Is there any chance of getting a chance to view it?
No, it's pretty low down, and it's a bit bright for the telescopes. What I could show you though, while Gary's going, this is one of my photos of just the eye of the seagull, which was the very I guess head of the seagull. You saw the broad wings in that last shot, and the eye of the seagull a bit higher. This is in the Sharpless 292. And that's an 18-hour exposure in different narrowband filters. So it took me quite a while to put that one together, but I saw that you're on that, so I just thought I'd throw it up for you.
Is that in false color or true color?
That's in narrowband with, I think, sulfur map to red, hydrogen alpha map to green, and blue map to, O3 map to blue.
Okay.
Yeah, it's quite strong in the sulfur channel, that one, of the filters for those familiar with narrowband filters. It's a 3 nanometer band pass filter around the frequency of sulfur in it.
Okay.
Will probably give us the exact number, I'd imagine.
No, I have to admit, there's certain things I don't memorize, and wavelengths and dates are two of them.
Yeah.
So why don't we take a look then at so yeah, if you can queue up anything live, Peter, that would be amazing.
Yeah, I'll try.
Yeah.
But I'm not that hopeful giving the Skycam at the moment.
Yeah, I saw the Skycam there. So maybe Jupiter. Can you do Jupiter?
Well, Jupiter, I could probably have a go, but with the style of camera I have, I need to chop it down to about almost a hundredth of a second to get any, because it's not a planetary camera. It's a CCD camera that's not really designed to photograph anything that bright. But
yeah,
I could probably have a go at it, but.
Well, I love to see multiple views all at the same time, and so whatever you think you can point at that will be really cool, then please let us know.
And
awesome.
That image of Andromeda that just came up is really awesome.
So why don't we switch and talk to that, because that one is live right now. So Gary again is blowing our minds here with his live view of Andromeda. So Gary, so this is of course the great Andromeda galaxy M33, located
31.
in the M31. I always confuse them.
Because
anyway.
it's the spud off to the side is M33.
And then the little tiny one's M110.
Yeah.
The one at the bottom.
Oh, there you go. And so you can see, you can see the galactic core. You could see the spiral arms there. I don't know if people can see this in their view when that they're looking. You can actually see the spiral arms, and definitely along the bottom, you can actually see like clumps in those dark dust lanes. And from what I understand, those are like nebula and other clusters in there. Whoop.
I just did that was a 1 minute exposure. I just did a 2 minutes, so let me scale it out here. We get a little more detail.
Are you doing log or linear scaling?
This linear.
Oh yeah, okay. I can see more detail now. I can see up at the top now. I see even more of that nebulosity up at the top. Right? Is that star formation there, Pamela?
It's star formation and the gas around the stars that's getting illuminated. One of the fabulous things about star-forming regions is the hottest, brightest stars are all in these baby nurseries, and so these really hot, really young stars give off just tremendous amounts of light, thousands of times more light than our own sun does. And so just having a few of them embedded in a small cloud is able to create a vast amount of luminosity. Now, I was actually wondering, can you drop the nucleus of Andromeda off the side of your chip and take a picture of the arms? Because one of the things about Andromeda that always blows my mind is this sucker is 3 degrees across. If you could see with your eye the expanse of the arms, it's 6 lunar diameters across the sky, but because the nucleus is just so much brighter than the arms, you don't get to see them unless you cheat and do something like move the nucleus off your chip.
Let me give that a shot.
I don't know if that's something you've done before. That was my favorite trick.
That I haven't. Let me, I'll put it on 5 second and jog the scope over a little bit. Okay. I'll go to the lower right because there's some nice detail in there.
Okay.
Sharin Ahmad asked, is it a C14? Yeah, Gary has a C14, but the kind of strange setup about Gary's telescope is that he's got the camera connected on the front as opposed to on the back. And what it's again? It's a prime focus.
Prime
is that
focus
right?
camera.
Yeah, it's a prime focus camera. So normally with what Gary has with the C14, it's doing the light comes in, bounces off the back of the telescope, comes forward, and then there's another lens inside. It bounces off that and then comes down out the back. and that makes them nice and short and sort of a lot easier to move around. But in this case, Gary's, it goes in the front, bounces off the back, and then goes straight into the camera. So there is no eyepiece on the back of the telescope the way most C-14s would work. And it's because he set it up perfectly for this exact thing, which is to get a ton of light on a very light polluted Los Angeles sky. So
Yeah.
And I get a lot of airplanes going through. And it's
What's the coolest image of a plane where it didn't belong?
That's a good question. I don't know. I can't think of one. I've had the police helicopter go up with their spotlight. That definitely ruined. That definitely ruined the exposure.
Yes.
Well, that's a nice Andromeda.
Yeah, that's gorgeous. Now that one is going to be a log scale. Did I guess your technique?
But this isn't live. Just need to make sure that people understand. This is a photograph that was taken by Peter.
So the reason that
go ahead. On this one, Fraser, I think Andromeda's set now in New Mexico, and about an hour ago I took this off one of the color camera telescopes there. So we had, I've got, throw up the scope. This is a Takahashi 106 FSQ with a color camera. So this one doesn't have filters, and it's just a color CCD, much like the CCD chip in a digital SLR, similar sort of thing. So that's what that one is, and it's set now in New Mexico. So I thought I'd grab that one about now for you, just to give you an example.
And how long was the exposure on that?
That's a 300-second exposure. I'll just flick it back up for you.
So 5
but
minutes.
You can see the dust lanes there, and it's just a stunning target. And as Pamela said, in a wider field of view, it's just gobsmacking.
Yeah.
So, as requested, Pamela, I think Gary's bottom corner is starting to show up now.
Yeah, and I've got a question for you, Peter. What do you do in the remote? What do you do about lens caps and that kind of stuff?
Yeah, well, when you're doing remote astronomy, there's a lot of things. Obviously, the setup that I have, I work with a number of partners, and they have things like interferometers looking at the sky. They have weather sensors, and they open the roofs for me. And lens caps, typically, we don't typically have them on most of the time, but we clean the mirrors down of dust every couple of months and take new flats, so yeah.
Okay, because I always wondered that. There's some gorgeous scopes in New Mexico. There's some areas that just I drool over. And I wonder, what do you do when all of a sudden, oh, I forgot to take the lens cap off. You can't just drive over and do it.
Well, a lot of people are using what's there. It's called like a flip flat. That was the name of it. It's attached to the front of the telescope, and it flips over this luminescent light thing to do flats with, and they just leave that as the cover of their scope. And then when we're taking it, they just flip it back, and it's all automated.
So we've got a few requests now, Gary. So someone is wanting to see M76, which is the little Dumbell Nebula, which should be pretty high up right now. It's in Perseus.
Yeah, we should be able to get that. Okay, this is a 1 minute exposure that you're looking at right now.
Yeah, the arms are faint.
But you can see more of the dust in here.
Yeah.
And you can also see another thing that they may confuse people as vignetting, the dark area around the edge.
Yeah, I was just going to ask you if you were using any calibration frames.
Yes, when I take shots, I have to. So what he's asking is I'll take a frame that's just looking at white light and subtract it from this, because the way the lenses are arranged, you can't get full illumination everywhere. on the CCD chip. In fact, with this kind of scope, you'll always have the most right in the center. And as you go off, you get less light. So if I take an opposite picture of just a flat blank field, I can subtract it from it.
And so is that why you're getting its light in the middle of the actual, just the star field that we're seeing?
Right. Because in this middle area, I'm getting all the light the scope is capturing. As we go off to the edge, less and less from the mirror is coming in.
Right. And so it's like the middle is getting overexposed while the edges are getting less exposed.
Right.
Right.
Now what's amazing is you can still see star clusters out to right below where your pointer is right now. Ah, you moved it.
Yeah, right there.
Yeah, and then
further to the right.
Yeah, down into right there. So you can see, even without being able to make out the details of the arms, you can start to get a sense of the true expanse of the object.
And my guess is this is a cosmic ray.
Yeah, that is a cosmic ray.
I don't remember any things that look like that out there.
No.
Okay, M76.
M76.
That's right on the meridian in New Mexico. So I do a meridian flip. Damn.
And so M76, for anyone who's never seen that, that is the Little Dumbell Nebula, or the Barbell Nebula. Yeah, and it's a planetary nebula.
So I blame these star parties for the fact that when we had the very first star party I got to join, I hopped on the Sky and Telescope website to buy a new copy of the Royal Astronomical Society of Canada's Observing Handbook, which is like the best handbook for North American observers, and it's been sold out ever since. And I blame you, Fraser.
Oh, really? For getting you to buy the latest copy of that?
No, for causing such a demand.
Oh, really? You think it's my fault that everyone's trying to buy observing handbooks? Is that one right there?
No,
I'll use my iPad.
Yeah, he's using his iPad. The thing I love about this device is they have, not device, it's a book, which I guess is still a device.
It's a kind of device.
It's a very analog device.
Yeah, there it is.
But with the handbook, there's tables that you can look at really easily. So I just, need to bring home last year's.
But it won't show you the positions of the planets and stuff.
Right, exactly.
Yeah. So there it is. Can you embiggen it in any way?
I am. I'm doing another exposure of it. That's just my...
It's just really tiny.
Yeah.
Sadly.
Again, this is sort of one of the problems with Gary's setup is smaller objects like this look kind of small. But the big objects are even possible to see. For most telescopes, you can't even see them.
See, there I'm zoomed in 400%.
Yeah.
Now, I can go non-bend in a longer exposure, and let's see what we get.
What's your finder scope?
It's the Orion Short Tube 80, and then the Orion Starshoot
So
Auto
this
Guider.
is going to sound dumb, but I'm betting this would look fabulous through your finder scope.
Yeah.
Yeah, but I don't have a camera that's worth. Yes. It's 80 millimeters, so.
Yeah. That's my dream scope. Is I really want a 70, 80 millimeter refractor.
Yeah, and it's the it's the Orion. It's not an expensive one, but I put it together with their auto guider before they made it as a package. And then they decided that they'd put it out as a package, and it makes a great little auto guide package. Yeah. It's just wonderful.
That's cool.
Now, when you say auto guide, what does that mean? What's that?
Okay, one of the things we do when I take long exposure photography, let me get this set up. Okay, I'm doing exposure now. When I take the long exposure stuff, the mount cannot track accurately enough to follow the Earth. The stars aren't moving, the Earth is.
Yeah.
And the mount's pretty good, it follows pretty good, but what I've got is a second scope on there that either 1 second or 2 seconds, depending on what I'm looking at. I'll set it for an exposure every 1 or 2 seconds. And it'll take a picture, and I'll tell it, track this star, and then it'll feed back to the mount and say, oh, move a little bit back. So it'll constantly readjust the mount to follow that. So I can do an hour-long exposure. Without it, the stars would just be pretty big blobs.
And you've got a similar setup too, Roy, don't you?
Yeah, I've got the similar setup on mine. The good thing with guiding is you don't have to, like Gary said, you don't have to have a mount that's perfectly polar aligned. So without guiding, I can maybe get 2 minutes before I start really trailing on my stars or they start bloating. But with guiding, it can get down to sub-pixel guiding, so it's always perfectly centered.
Yeah, and I know that when your views of Jupiter and stuff, it's just there.
Yeah, that's just
hanging.
the mount. That's not even the guiding.
Oh,
Yeah.
really? That wasn't even the guiding, yeah.
I use only the guiding for any long exposure stuff that I do, anything over 2 minutes or whatever.
And the thing that just completely blows my mind is when I was in graduate school, not that long ago, we were still guiding everything by hand, and just the fact that everything is now automated is just phenomenal. I mean, we were starting to get auto guiders, but we were just starting.
An eyepiece with the little crosshairs on it.
We weren't that low tech. We
Okay.
had one of the S-Big ST4s, and
Okay.
every time they read out, they do this da-da-da-dum thing. So we had that set up, and it was doing readouts every however many seconds we set it for. And we draw with a grease pencil on the monitor an X to mark where the star started out on the chip. And we tried to keep the star lined up with our grease pencil mark.
I think that's probably your best view there, Gary. I think at that
Yeah.
sort of magnification. So you're actually magnifying it digitally beyond what the telescope is viewing, and
Nope. Yeah, I'm trying to get the dark down a little bit.
Yeah.
Yeah,
It definitely looks like a dumbbell.
Real tight area.
That's even better because you can start to make out the figure 8.
That is full resolution of my camera. So there's no binning, and I'm zoomed in at 100%, so you're just seeing the center part of the picture. If I take it back out, let me do it 25. That's my full frame right there.
Yeah.
So you can see that it's in the center.
Teeny tiny.
The hydrogen alpha filter is probably hiding a lot of it too.
Oh, I'm sure it is.
Yeah, this is a planetary nebula, and one of the reasons that they're so often green is because they're bright in oxygen. It just happens to be the thing that is happily glowing most often.
Now you have an oxygen filter on this telescope, right?
I do.
Do you want to try switching to the oxygen filter and see what happens?
I can absolutely do that.
That is awesome.
Let's see what we get out of that one.
Does your telescope also make espressos? Because I'd like one. That'd be nice.
Yes, it does, but it doesn't deliver.
Okay.
You have to come here and pick it up.
That is a phenomenal telescope, yeah.
How's your focus going to be on filter changes?
The oxygen is going to be pretty close. The focus is off right now anyway. I've got temperature drift, but with what we're looking at, I could accept a little focus off. That is one of the other disadvantages with shooting fast, like I'm doing, what they call a fast scope or a low F ratio. The focus is much more critical.
Yes.
So I find in an average evening, I'll have to, if I'm doing a 3 or 4 hour shoot, I'll have to refocus every 45 minutes to hour.
Oh wow! I have mine automated set up, and it refocuses every 20 minutes.
Ah. Yeah, that's the next step. I started to play with that and never got that far.
Well, then after that, you go to temperature compensated, so you never have to focus.
Okay, here we come.
I'm actually thinking we should, I'm always not wanting to do, look at photographs, but I'm thinking now that we should probably do a separate hangout and just get astrophotographers in and have them display some of their photos. I think that'd be really neat.
Let's organize that for Wednesday night for the weekly science hour that we're doing on CosmoQuest, and that way we can maybe follow it up with a real star party as it starts to get dark.
No, that's a good idea. So like another hangout is what you're saying.
Yeah.
Like do another show, another hour.
Well, it's the hour I just finished doing, so I'm happy to host it.
Right, okay, all right. Was that the first one that you've hosted?
Yeah, it was the very first one. So we didn't have a huge turnout, but I didn't do a lot of promotion because I was kind of worried that the technology was going to self-destruct.
Yeah,
but it didn't.
It should be.
It was kind of awesome.
That's good. So is this with the filter change? No.
Yes, that's the oxygen filter, and it's a 60-second exposure.
Looks about the same.
Yeah. when you combine them, you can see the differences. But
Yeah.
So one of the things that you have to factor in is telescopes aren't equally accepting of light in all colors, and so some telescopes are really sensitive in the red, some are more sensitive in the blue, and you start off from the magic ratio for the telescope I used was if you took a 60-second exposure in the R filter, the red filter, you'd then need to take a 90-second exposure in the V, the green filter, and unfortunately even longer than that, something like 180 to 200 seconds for the blue filter, because that telescope hated blue. So I don't know how much we're dealing with the fact that, yes, it has lots of oxygen light, but the telescope just says don't care.
yeah, and it's also with the filters, since there's so much hydrogen out there. I'll usually take 2 to 3 times exposure time for both the oxygen and the sulfur, just because hydrogen loves to glow.
Yeah. Okay, well let's move to something else. We did the Crab Nebula the other night. Do you want to try M1?
We can do that. That's always a nice one to look at.
Yeah.
So we need more big objects. Unfortunately, Sagittarius is not anywhere near above the horizon right now. It's kind of
All the big objects I'm finding are too faint.
Yeah.
And there we're slewing.
You have to figure out what is the direction of your actual camera, because we had one time where you're trying to view something and it ended up gazing right down at the camera. We could see right down the telescope. It was really cool.
I can show you that.
Yeah.
Let's see what we got here at
M1.
Yeah, I'll just try a quick capture. I'm still on the oxygen filter.
I hear your cat, Roy.
Yeah, I'm muting.
No, I'll scare everybody for a minute and let you see me again. And I'm a little purple.
Yeah.
These cameras do that. I always come out looking Oompa Loompa in the evening.
And I'm always red. So it's just like the light, it's the camera, it's the software, who knows what it is.
Yeah.
And if any of you out there listening have solved the lighting problem, we want to know what you did so that I don't look like an Oompa Loompa and he's a little less red.
Yeah.
You get flat light LED lighting, which is not cheap. This is fluorescent right now.
Yeah.
Yeah, fluorescent is...
Death.
I think Roy is being lit by his monitor, I think. Or if you got some light coming in from the side.
You have one desk light. It's a good desk light. We had one person join us in a hangout who was lit entirely by his monitor and there were no other lights on.
Yeah.
And he looked absolutely amazing. It was really cool.
Yeah.
Yeah, if I turn it off, it's not enough. And if I shine it on me, it's too much.
Yeah.
So did anyone see that Jerry Ryan did a hangout today?
Yeah. That was kind of awesome.
That was really cool. Yeah.
I spent about 2 minutes in there and went, yeah, okay, I'm really into this.
I didn't have a chance to join, but I heard all about. Well, I didn't hear all. I heard it exists. Tell us the details.
Yeah. Yeah, well, I didn't get a chance to watch too much because we were trying to prep, but I know that she had been threatening to do a live hangout and actually did one, and it went really well. So,
cool.
Yeah, and a lot of people were in it. A lot of people were commenting on it, and also Felicia Day and Veronica Belmont have done a live on air, and I think Will Wheaton mentioned that he'd like to try and do one too. So.
We're here to help if any of you need tech help.
If anyone needs help, yeah. So this is great. So is it? Can you muck with the contrast on this one? What's your exposure time on this one, Gary?
That was just 60 seconds. I'm doing that's an 03. Now I just set it back to hydrogen. I'm going to do a 2 minute.
Okay. And so this is M1. This is the Crab Nebula. This is the great supernova that happened in 1066, I think.
It was detected by the Chinese.
Yeah, so it was clearly visible with the unaided eye as a new star that appeared in the sky. And what's amazing then, right, is that we're seeing it just 1,000 years after it happened, and this is the result. This is the, spreading supernova remnant that's being created.
Supernova really are something that get much better with age. 1987, I think it was 1987A.
Yeah.
The supernova that actually Phil Plait didn't discover, he studied as part of his research. When it first went off, it was this little tiny figure-8 thing that you could really only see with the Hubble Space Telescope. But over time, as it expands and lights up more and more of the material around it and gets larger and larger, it's actually going to just get better and better over the generations of humanity. So it's sad when you need to think multi-civilizations in the future. It will look awesome.
Yeah. They're the same people who are going to be able to enjoy Betelgeuse or Eta Carina exploding.
See, there you never know.
Could be us.
Could be us.
Yeah. Although not us, because we live in the, if Eta Carina goes off, we live in the northern hemisphere, so we won't get a chance to see it. I'm booking a flight.
Have airplanes.
Yeah, I'm booking a flight. If Eta Carina goes off.
That I would fly for.
I've always wanted to be on an A380.
Yeah, they're fun as long as they're not pointed at you. The supernovas.
Okay, I was going to think who's pointing an A380 at you.
I just, sorry. My wife smacks me up the side of the head when I do that. I knew what I was thinking.
And so for anyone who's kind of just joined us, if you want, you can full screen the Hangout. Have you seen they've added this new button to it, Pamela?
No, I haven't.
Yeah, so if you're watching a Hangout, a live on-air Hangout, there's now a little button in the bottom right-hand corner that you can click that will maximize it full screen, and then you can hit escape and pop it back down, and it's instant. It's really nice.
Awesome.
Yeah, it's really cool. And so always in the past, every time we've done one of these Hangouts, we've always had to tell people, if you want to see the live on air, or see it full screen, you've got to, hack the code, and there's an extension that you have to install. But now, boom, you can get it right away. So it's really cool.
Yeah.
And it's just now installed as part of the interface. So that's really cool. There is the Crab Nebula. That is so beautiful.
Yeah.
That's it.
Do you have any science for us, Pamela?
It's pretty.
Pretty.
Sorry.
Yeah.
It's last time we talked about this, we had Phil here, and he's really the supernova guy. So what's awesome about this is all those places that you see the brighter filaments through it. That's not really anything having to do with the way the supernova went off, but right now the light that was released in the explosion and the shock wave and everything else, it's propagating through the material that exists between the stars. And as it hits that material, it's lighting up. So the supernova is actually allowing us to, bit by bit, map out the material that was surrounding the star that exploded. And some of this material was actually released by the star itself. So it's one of these interesting situations where the star at one point had massive stellar winds, spewed all sorts of material into the space around the star, and then when it exploded, the light lit up all the material it had given off in its childhood, basically. There's many different examples of this, and perhaps the most dramatic is, I believe it's V838 Mon, which was a we're still sorting all of the details, but it looks like it was a fairly normal star that gave off this sudden flash of light in 2002. And as that flash of light propagated through the surrounding material, it turned out the surrounding material had this amazingly detailed and beautiful structure. And there's this year after year after year set of Hubble images that show how the light has expanded out, illuminating larger and larger volumes of space. And
that's not a supernova. I mean, that's just nova outbursts, right?
Yeah. that was just weird outburst. It
Yeah.
didn't. Nova implies explosive event. V838 Mon was something just plain weird. It gets in the same thing as like Eta Carina did something weird. Sometimes stars just hiccup.
Hiccup. Blast out something.
Yeah.
Stuff. Well, that's gorgeous. That's amazing. Now, Peter, what have you got there? That looks...
That was my M76 from before, but as you can see, it's looking very misty. I think I'm pretty much clouded out now. So you can make it out just in the that little part there. This is a star that's got some cloud and mist around it. But
so was this? But you took this one tonight? Like just now?
Yeah, that was just yeah. So I don't think I'll be able to get to M1 with that's clouding in pretty heavy now. So.
Oh man, that's too bad. I love the color view though. It's really nice.
Yeah, it comes up a treat. Although, as you said, the Dumbell's pretty small, so it's not that good on a large field of view scope like that one.
Same thing. We don't have any of our planetary people on tonight. So unfortunately, it's all deep sky stuff tonight. Well, not unfortunately.
So what we're really missing is we need to find one of your down under colleagues who has a solar scope, so that we can actually start seeing, now that we have such an amazingly active sun, start taking advantage of that and bringing in the sun during our star parties. It is, after all, the closest star. Yeah,
true, very true. And of course, down under is the capital city of solar. In November this year, there's going to be a lot of people coming through North Queensland to the path of totality. I know there's a lot of cruise ships booked, and I know there's people going on the annual eclipse journeys to take in that eclipse. And if I can do a bit of a Tourism Australia ad here, if you can imagine standing on the beach overlooking the Coral Sea at 8 o'clock in the morning and then see the sun not far above the horizon and then go into a total eclipse for the next hour or so, well, that would be absolutely spectacular.
Yeah, I'm really hoping I get invited to come down for something. There'd been this very brief and probably forgotten discussion of holding a couple of conferences down there during totality, and I keep hoping.
You just want somebody to pay for it, that's all, right?
Yeah, I have to admit. I work for a state university.
I know.
I'll sing for my supper, just pay for the airplane ticket.
Hit that donate button now. Yeah.
So, okay, well, that's awesome. There's M1. Now, Roy, you mentioned M78.
Oh, wow.
You want to try that? What's this? You already did it?
That is phenomenal.
Sorry, that's the Rosette. I had you muted. My wife bought in a bowl of wonderful tortilla soup.
That's really
like.
So that's the Rosette Nebula, right? That's live, right?
Yep. That's
just
amazing.
60-second exposure.
Wow.
Can you try zooming in on some of the dust lanes?
I can. That's 100% at this point because I binned it. So
okay.
We can come in and look at like this.
So dust lanes is kind of an understatement. These are thick molecular. This is like if you want to find formaldehyde in space, you look there. These are cold regions packed with molecules, everything from alcohols to amino acids can get found in some of these dark molecular regions.
That is phenomenal.
The final images, those things just pop out.
Can you zoom back out? Yeah, or unzoom? I mean, it's just such a beautiful wide field of view. That's phenomenal. Look at that. I hope people who are watching this can see this. This is, I'm going to say this is my favorite one. I think I like this better than I think I like this better than the M42 and the M31. That is just outstanding.
When is the Omega up? That's my favorite one. And you could you could just do a fabulous job on that one. I'm doing 2 screens. I'm sorry for everyone who looks like I don't know where I'm looking. I'm checking Chrome.
M17, isn't it?
I can't remember numbers to save my life.
Can we just why don't we just leave it on this, and we'll just leave the Hangout running for the next couple of hours and just gaze at it. Could you know what? It would be kind of cool, Gary. Could you do a astro photo of this? So do you want to try like doing maybe doing like a shorter exposure one, but actually kind of taking people through the process, and maybe you could produce the final picture and we could post it on Google Plus when we're done.
Yeah.
Yeah, I don't want to use up your valuable time, but because I think this is just phenomenal, and I think I could just imagine if you did your 3 filter. If it's too much time,
No, you know what? It's not. Let me. I've got the hydrogen. The focus won't be good because I'm not going to focus in between. But something like this, we can live with that.
Yeah.
So that is. Let me mark this down.
And also just to sort of show people what the process is, right, and sort of see how the whole thing comes together. So if you want to sort of talk people through it, that would be really neat.
Right. Okay. So what I've done right now is I'm set at 1 minute, and I renamed it so it's it tells me it's the hydrogen alpha, and then I'll do a quick shot on the other 2. So do a couple minute, and then what I'll do is I'll increase the screen size so you can see the software that I use.
Sure. And then maybe if I'm not sure how long it process. I mean, it will merge them all kind of instantly, right? Once you got the 3 images.
Yeah, it depends on how far I want to go. Normally, I will take each one and do the flat picture against it, the flat field, and then also noise. So I've taken, I've gone through with the camera all the different temperatures, and I've taken the different noise, a noisy picture. So I subtract the noise from it.
Speaking of noise, sorry, we've got the noisy astronomer just joined us, and Nicole, I just muted you. Sorry that you got some weird background. Oh, there you are. You're back now. You can unmute yourself now, if you know how to do that.
Is it working?
Still staticky.
Oh, it's working now. It just usually takes a second to calibrate. No, it is pretty staticky.
What turns that? Okay, I'm going to mute again.
Okay.
But excellent segue.
The noise.
So I have a question for y'all. Is there a good online calculator for local standard time? Because I'm trying to figure out what the standard times are in different time zones, and I'm thinking this is a solved problem. So the reason that I'm asking this is in astronomy we have to deal with the annoying fact that the stars are not in the same place from night to night, and you can tell what is straight overhead if you know what's called the local standard time. And local standard time basically is, if you imagine that the planet is a clock, there is a star that is denoted as having hour 0, and when it is straight overhead, it's 0 hours. When it's straight under feet, it's 12 hours. And you can use this system to figure out what is the best thing to observe. And ideally, you want to observe something that has a position in the sky called right ascension. It's in a position east to west that places it as close to straight overhead as possible. So if you know your local standard time and you find an object with the right ascension that best matches your local standard time, you're going to be looking at something that is optimally located. But I'm failing to find a clock online that says what local standard time it is for all of these guys.
That would be. We've been playing around quite a bit with the API for the Hangouts API, and to have a some kind of gadget over top of your screen, like a lower third that shows what your local time would be really useful.
That would be awesome.
What people's time zone is.
Have you tried the Time Buddy in Google Chrome? Google Chrome Time Buddy?
No, I haven't.
Plugin. That gives you, when you're setting up meetings and star parties and hangouts like this, you can work out, you add in all the cities of the people, and it'll tell you what time it is in their area at the time that you set up the meeting. So that's quite handy. I don't know if that that doesn't have any correlation into.
Doesn't help with local standard time, but it does help in general. It solves other problems I have.
Yeah.
So Gary, what are you doing now?
This is in the light of sulfur 2. Same scene, the sulfur 2. I'm now exposing the oxygen 3. You can see the same form, but in something like this, it amazes me, the difference. This is a lot of hydrogen out there.
Pamela.
He said sulfur. I have to admit that's something I don't know very much about.
About it, you don't know much about it. Sulfur, just the different filters.
Yeah.
Just the fact that the.
So one of the benefits and problems of doing narrowband photometry is because he's looking at specific wavelengths that are produced when a sulfur atom goes from one excited state to another. He's getting rid of all the light pollution issues, but at the same time, there isn't that breadth of getting all the green at once, getting all the red at once, and so you start to be able to tell, ooh, this object doesn't have that in it, does it? As you look.
And so this is in the oxygen.
Yeah. Excuse me.
Wow.
I'm working here.
How's your microphone, Nicole? Is it still the same?
And Nicole has the best lighting of all of us.
Yeah.
Is any better?
Excuse me.
We need to like give her our audio and steal her lighting.
Is it still making that noise?
No, it's good.
You're
Oh,
fine.
okay, good. Pat, I just put in the chat. IDL have you used CT to LST in IDL?
Oh, not often because my IDL license I have to pay for out of pocket. Yeah. Yeah. Don't worry, your position will come with an IDL license.
Yeah. Good, because I'm at a Python right now.
So Nicole, when she finishes her dissertation, is going to be coming up to my neck of the woods, and we're going to be sucking her into our little den of astronomy, open awesomeness.
Welcome to the dark side. Hey, that was a pun.
We have cookies.
Do you have radio telescopes?
No, but we can always build one.
We can build one.
Hey, that's a good question. We got all these amateur astronomers with telescopes. Is there any amateur radio astronomers?
Yes, we just haven't found one yet.
They are incredible astronomy ninjas. They meet out in Green Bank, West Virginia once a year, and so I met a group of them, and they just build these fantastic telescopes from satellite antenna dishes, and detect molecules and all kinds of cool stuff.
What's kind of amazing is historically, some of the first catalogs of radio sources were actually done by an amateur astronomer who had a professional astronomer come to his house and basically go, seriously, dude, how did you do this? Before they'd allow the paper to be published.
Yeah, we started about Grote Rebirth.
Yeah.
It's kind of awesome, yes.
So what have we got here?
All right. I've expanded the screen. Is my audio there?
Yep, I can hear you.
So you can see the whole nebulosity that I use as I choke here.
Please
don't do
choke.
that. We want you to come back again.
Oh, don't get old. It sucks.
Right.
So the real quick run, I'll pre-process black and white. So I'll first pick a dark image. Oh, I can't do that. It's on my other machine, so I'm just going to combine these. Basically, what would happen here is, is I would pick a dark image that's based on that I've taken before at certain temperatures, and so it will subtract the noise, and then I'll take the flat, add a flat that'll take this vignetting out, and that will get them. Yeah, I know. But just for a real quick one, I'll do an LRGB synthesis.
That LRGB is luminous to get the color contrast red, green, blue.
Yep, sorry about that.
It's all right. This is why we have a job, because we need to translate acronyms occasionally. That's the only reason we're here.
Yeah, that's why I shouldn't have to prompt you, Pamela, when I hear this jargon roll by and we all like stare stunned into the camera. That's your chance to jump in and translate.
Okay.
The what? LRG what?
I did catch it that time.
Yeah, no, that was awesome. And now we've doubled our astronomers now with Nicole. So.
Yep.
I got the low wavelength then.
Yeah.
It doesn't make pretty pictures.
Should we do that? Should we like have a telescope party where we're doing radio astronomy? We're listening to the static.
We need to do a meteor shower that way.
Ooh, that would be cool.
Yeah.
Well, I think the only thing people know about radio astronomy is what they saw in the movie with Jodie Foster. With Contact.
Oh, Contact?
Yeah.
Yeah, that's so sad. Everyone needs to go. There's this. Oh, what's it called? The movie about the dish,
that's great.
which has the story of using, what was that? Parks
Radio Telescope.
Yeah.
Parks Radio Telescope to get the TV signal from the Apollo 11.
Yeah, in Australia. That's an awesome movie. Well, I just showed my daughter Contact now for the first time, and she's absolutely hooked. She is trying to show it to everybody.
She needs to see October Skies. That's perfect for her age.
That's another good one. Yeah, you're right. October Skies. Yeah, we'll do that too.
You want to give a summary to the audience that now is like, what are you talking about?
October Skies or what?
Yes, it sounds rather like a anti-Soviet movie.
October Skies is the movie. Well, it was based on the book called Rocket Boys by what's his name?
Starts with an H.
It starts with an H. I know. Herman Howard.
He was
anyway,
mission director.
I can't remember.
This is why we have Google.
Someone will find it.
We love you, Google.
Yeah.
Homer Hickman.
Okay.
Homer Hickman. That's right. Yeah. So it's based on his book, and it's about a bunch of amateurs building some rockets.
More importantly, it's about a bunch of kids in a completely impoverished mining town that get into building rockets, and it completely changes their lives because they win the National Science Fair. So they got out.
I will dig that up for my daughter. Did you see the cool footage of some Canadian kids that hooked up a little Lego man to a weather balloon and shot him up to the edge of space?
That's awesome. No, I didn't see that.
Yeah, and again, my daughter's like, could we do that? Yeah. If we're willing to lose a camera.
Relatively cheap to do it, like $65 or something.
You can buy these high altitude weather balloons off the internet for reasonably inexpensive. You just got to be willing to sacrifice a camera because you need to. You pretty much want to use an iPhone, right?
They're fairly easy to retrieve, actually. Last summer, I got to work with the International Space University over in Graz, Austria, and this is a group of absolutely amazing individuals who sign up to take a summer course on basically what is everything you need to know to run a space agency. And I was just there to give them the new media piece. But this group of amazing students doesn't seem like the right word. Professionals getting professional development. One of their projects was to launch and recover a weather balloon, and they tracked it as it basically wandered all over Europe and then came back to where they could get it.
Yeah, so for example, where I live, I've got water to the, in many directions. I've got horrible mountains to try and scale. Like, unless we were really lucky, it would end up somewhere, and then it's just, crazy forest. So unless we were super lucky, it would be irretrievable.
So it's a dedication problem rather than anything else, because you do own a boat.
Yeah, right. So I just, I guess that would be the way to do it. Take it out into the middle of the water, fire it up, and then, chase it on the water.
Yeah.
Yeah.
Okay, I can run through a quick one here for you.
All right.
I'll pick the red frame. In this particular case, I'll pick the hydrogen. Grab the green. For the green, I will use the sulfur. Now, hydrogen and sulfur are both in the red range. So this is where you come false colors. I just have to pick it. The blue, oxygen is more of a green, but it works out nicely for the blue. So I'll select those three, and then I'll apply them. and do a little bit of adjustment to get the basic colors. There's a little too much blue there, and it's pretty faint right now because I haven't done any stretching on it. So we'll bring the blue down. Okay, that's good enough to start. Okay, so I'll say okay on that. Now what I can do is, the image, first thing I'll do is I'll adjust the background color, and it makes a pretty good guess. It says you were too blue, so this is a feature he's got. I can adjust this where I want it to be, but that guess is pretty good. And I've got several ways that I can start stretching this or developing it. I can try a digital develop. Let's see what that comes out as. No, I don't like what that's doing. That's one of those, sometimes it works and sometimes it doesn't. So what we'll do is come up with the levels and power.
This is the black magic part.
Right.
Yeah.
So this is a histogram of what's there. So you can see there's very little down here in black. This is total black. This is absolute white. So most of the pictures in this range. So I can start stretching this down a little bit. I'll stretch the center a little bit. Do a done, and then I'll bring up, don't have enough hands. I'll bring up the dark.
Oh, I'm starting to see it now.
Yeah, and you see it's showing me what it was and what I'm bringing it into.
Yeah.
I'll put the dark about there. I'll do another center stretch to get it right in about the middle range. I'm going to bring the white down a little bit. This is the time-consuming part.
This is the part I can never get right.
So if this is something that you struggle with, there's this great piece of software called FITS Liberator that you feed it the FITS images you take with your telescope, and it has these amazing interactive tools to help you stretch your image in a variety of different ways and get all of the balances just right, and it works with both Photoshop and GIMP.
Ah.
Oh, it does work with GIMP.
Nice.
Yeah, it works with GIMP.
Oh, I've only ever used it with Photoshop.
Yeah, it works with both. They recognize not all of us are crazy enough to pay for Photoshop. I am that crazy, but not everyone is.
Photoshop is the most complicated piece of software I've ever used.
So
GIMP,
awesome.
GIMP is 10 times as complicated.
Yeah.
Yeah.
But seriously, you give a person Photoshop and say, draw me a circle. They cannot do it. If they've never used Photoshop, they don't understand how it works, right?
Well, you
GIMP, you know, it's the times 10. Look at that. That's beautiful. Oh, man. That's really coming out.
Oh, wow.
Now, what I just did is I did curves,
Yeah.
which is from Photoshop, and it also lets me adjust it. And there's some preset ones, and the contrast usually works out pretty well. So the line here is where I was, and these are the points. So I've stretched this way and this down a little bit. So we do that. Now, it's not going to come out good because I don't have a good flat field. You can see how it's getting orange and dark here, and it's still light in the middle. If I flatten the picture so that the illumination was equal all the way across, I can get a lot better than that.
Nice. And
We've also only got one of each channel.
Excuse me?
You've only got one image of each channel as well. You usually take, 3
absolutely.
hours worth
Yeah.
and stack them together to get some really good, get all the noise out of it and everything.
Oh, yeah. I didn't do flattening. I didn't even noise reduction. This is just literally taking the 3 and turning them into color. And
This is as quick and dirty as you can possibly get.
Yeah, I really put
It's
you on the
still
spot.
gorgeous.
Oh, there, that one right there. That one I like.
that's too much. I got too much noise in there.
Yeah, too much noise. All right. Yeah, no, I think, I put you on the spot, and so for you to be able to do this quick and dirty is phenomenal.
Yeah.
Well,
You may not be able to do photometry with it, but it's gorgeous. That's
Now you have to explain photometry, though.
Yeah, you can't
measuring the
word bomb.
brightnesses of the stars. Stupid words.
now that you're looking at that, just show you one other piece where I'll pick sulfur for the red, hydrogen for the green, and again oxygen for the blue.
And this is very common. So when you see those beautiful pictures from the Hubble Space Telescope, they're essentially doing the same thing that Gary's doing right now. So, you know, when you see those beautiful colors of, you know, the Carina Nebula or the you know, the Pillars of Creation and things like that, it's the same process. They're taking one image from one filter, a different image from another filter, and a third image, and then they are just putting those three colors together and calling this one red, that one blue, and this one green. And they'll also do it sometimes in 3 different wavelengths. They'll do one image from Hubble for the red, they'll do Spitzer for the blue, and they'll do Spitzer for the green, and then they'll do actually Spitzer red, Hubble green, and Chandra blue. Mm-hmm. And so what you get is you get infrared in one wavelength, you get visible light in another wavelength, and you get as another color, and you get X-ray as another color, all merged together.
Yeah, it's a bit wild.
Because otherwise, what's the color of X-ray? You really can't.
Yeah.
Everyone knows it's blue.
It's very, very, very blue.
Very blue. Yeah. So this is, I mean, this is great to just sort of see the putting them on the spot here. And so I think, you know, I mean, this is where the real magic comes with astronomy, I think, is when you make that transition from visual astronomy, which is great and wonderful, and you take it to astrophotography. When you connect a camera up and you're able to capture big, long exposures, you're able to stack those images, you're able to play with all of the different kinds of light and the brightness, the contrast, and putting in the colors. That's where I think this hobby goes to the next level, for sure. And I'm really glad. You know, one of the big problems we always have with astronomy casts is it's all such a audio situation, and yet astronomy is so visual. So it's great that we can start to present you some of this visual stuff now too.
We've been getting better with time, but still, and I like talking with my hands.
I know. People never saw you talk with your hands, but now they love it. They're like, look at that, Pamela talks with her hands. It's so funny.
I didn't know you were Italian.
Shop than you are.
Yeah, it's quite funny to see her do this when we record Astronomy Cast.
Yeah, I didn't know you were Italian, Pamela.
I'm not. I mean, that's the crazy thing. It's like some English, Irish, Dutch, Native American crazy combo gets you Mediterranean? I don't know.
Oh, and I need to do a little bit of log rolling. We're going to be doing our weekly Space Hangout tomorrow at 10 a.m., and that's with, I don't know, Nicole, were you going to be there?
I think so. Yeah. I don't know if I have anything besides complaining about Python.
I don't think that's covered in the news.
No,
I can
but
assign
I think I could be there.
And Pamela, and I don't know about Phil. He's on some trip.
Yeah. You used to answer emails.
Emily for sure. Yeah, so it should be good. And we'll talk about a roundup of all the big space news that happened this week.
All right, there is now this one I understand is called the Hubble palette. When the Hubble does the hydrogen, sulfur, and oxygen, they'll make the hydrogen green, and I like it better. Or excuse me, the hydrogen green. I like the hydrogen as green. It stands out.
Sorry, Pamela, is this some little sign that you're holding up?
Is this a subtle hint?
Yeah, I'm trying.
It's not. Oh, is that Cam Twist?
I'm playing with Cam Twist.
Okay, all right.
So we're forever telling people. See, I haven't told it to save settings yet. I didn't know you guys could see it until I said save settings.
You can see it moving now.
Yeah, you see it moving around.
No.
Sorry, Gary, you were saying something really key here. Sorry.
Oh, yeah,
Sorry.
Just that when the Hubble telescope takes these three, they usually do it in the green for hydrogen, and it's called the Hubble palette. So that's just something. But the green... Yeah. In a lot of them I like. Some of them the red, it looks better as hydrogen is red. It's totally subjective. Mm-hmm. You know, I'm not doing any science here. I'm just doing pretty pictures.
And you'll actually see this a lot when they do Spitzer images. They love to make Spitzer images this green-red montage. It's apparently the new trendy thing to do in astroimaging.
And so everybody watching, this is you seeing how this actually gets done. This is how you see the pretty pictures from the Hubble Space Telescope. Gary is recreating the process for you in real time with his own gear and doing the software. And that's essentially how you see those images. It's really cool. Fabulous. All right. Well, I think we're getting to the end. We were hoping that we're going to have one more person join us and show us a live view of Mars, but he hasn't been able to show up. So.
Is that the Horsehead?
Yeah, Peter's got the Horsehead over there.
Ooh.
Oh, let's take a look at the Horsehead.
Is that live with your deteriorating skies?
Yeah. So you can see one of the things with Nebula. Is you can see a little dust ring on the mirror there.
Yeah.
And one of the things with the full moon is that quite often it'll show up any dust on your mirror, which obviously nebula are better with really dark skies, and we've got the full moon tonight. But that's if you want to throw that up on the big screen, Fraser.
Yeah, it's on the big screen right now.
You can still see it. Oh, is it? Cool. No. It looks really cool. It's a lovely part of the sky, and this is on my telescope now, which is quite a deep field telescope. It's a 20-inch plane wave, and gets it in nice and tight. So when you do what Gary's doing with that, you can come up with some stunning images. So I just checked, Pamela, and M17, the Omega Nebula, has set. So
okay.
We can't get that one tonight. I have got a nice file footage which you can see on my Twitter page, which is my background to my Twitter page. So if you want to have a look at it there,
I'll take a look.
What's your Twitter?
My nomenclature in the online world is Astro Swanee, because my name's Peter Lake, Swan Lake, being a musical kind of guy. I have the Swan Nebula, which is the same as the Omega Nebula, on my page, and it's quite a nice photo of it too. So you can see it there.
So
oh, go ahead, Pamela.
I was just going to say, what's odd is I knew your Twitter feed. I knew you. I didn't realize they were the same individual, and I now feel kind of dumb.
That's all right. Yes, well, Google like us to go by our real names, so.
Yeah.
Sorry. Tomorrow, 10 a.m. Pacific time, 1 p.m. Eastern time, 6 p.m. Greenwich Mean Time is when we do the hangout. It is always the same time. It is always 6 p.m. Greenwich Mean Time on Thursdays and 8 p.m. Greenwich Mean Time on Mondays. Monday we record Astronomy Cast. Yeah. Thursdays we do the Week Space Hangout. These virtual star parties are completely random.
And tomorrow will be a double header because we're trying to get ahead on recording Astronomy Cast. So we will be recording a bonus episode of Astronomy Cast after the hangout and a brief pause to refill on caffeine.
Michael, this is the. Michael Koppelman mentioned that I've got a very boring background in my room, but I've done this on purpose. I want a, nice, clean, boring background. I can move a little and show a sleeping child.
You need a green screen back there with the stars behind you.
Yeah. That's
you have a dead child behind you. That's totally awesome.
Logan came in quietly and crawled in and was watching from the corner and has passed out, which is pretty funny. See, a total professional. You had no idea that this happened, did you? Yeah. Yeah, I'm, with me judiciously muting while there's, while the kids are having fights in the house and doors are closing and all that. Yeah.
So you just need to cam twist a background behind you.
Right. Get a green screen going. So great. Well, this is fantastic. So this isn't the same image, is it, Gary?
This is a processed image.
So this is a different image that you did of the same
one that I took over long exposure just to show the difference.
Yeah. And you have it more centered in the field of view. What a phenomenal object, though.
Yeah.
Oh, yeah, it's gorgeous. So there's the...
And there's the one that you did tonight, but now it's green. So you've just randomly chosen green as the highlighted color as opposed to red. And that's just...
And now I can show you my process with green.
There it is. Yeah.
That's cool.
And so always, one of the questions that we always get on Astronomy Cast is, are you seeing is this what it would really look like? If you could actually float in space and see a nebula with your own eyes, is this what you see? And the answer is absolutely not.
Your eyes are terrible, terrible detectors for astronomy.
And one of the
better.
One of the completely crazy things that blew my mind in grad school is they give you these horrifying homework assignments where you're calculating the number of particles in a variety of different states per volume of space. And you're realizing that there's like 5 atoms per cubic meter in a nebula, and it's like more vacuum than anywhere on the planet, and this is a thick nebula. And you suddenly realize you could be standing in the heart of one of these glorious nebulas and be completely unaware of it because the gas is just that diffuse that in order to see it, you really have to get far away, and by far we mean light years away. So it's kind of crazy. If you fly through it, it's not at all like Star Wars or Star Trek.
I was going to say, the scenes in Star Trek where they fly into my favorite is when they fly into a dark matter cluster, and it's like, really?
Let's hide in the Meteora Nebula.
Yeah.
Yeah, they hide. That's right, they hide.
Yeah.
So you can hide in a dark molecular cloud, but all of these pretty glowy things, no.
So Mark has just joined us, and right now we're only seeing Mark's minicam startup screen, but he promised us Mars. He promised us Mars.
Yay.
It's not a very exciting image. It's just a little red dot.
It's a
It's a red dot that has a pole.
Can you see the pole in your view?
If I squint real hard, maybe. I'm working with some pretty basic equipment here, so as soon as where did my Manicam thing go? Sorry, keep talking. Go ahead.
No, we're just all now like sitting here on the edge of our seat.
Waiting for Mars. You'd better.
Please don't. It's not that good.
This had better live up to our expectations,
It's
Mark.
still the red planet.
No pressure.
Even a bad Mars is a good Mars? I don't know. Does that
Peter, you're displaying, is that the Swan Nebula?
Oh.
Yes, I put that up just for Pamela. That's my pride and joy. I'm very proud of that photo.
It's a really good one.
Very nice.
You do amazing color work.
Phenomenal.
Now, is that multi filter or is that with a color chip?
That's just RGB, I think. Might have some luminance in it as well, LRGB. So again, it's some luminosity mapped to that luminous channel with RGB, just red, green, blue, which are wideband color filters on a crank camera.
Yeah, that's awesome.
Oh, there it is. There's Mars. So Stuart just pinged me, and he said that he can show up in about 20 minutes. If I'm going to see how his seeing is. I don't know if people want us to just keep going for a little while. How's your time, Gary?
I'm pretty good.
Yeah.
I need to do a couple things with the wife here, but I can hang around.
Yeah. All right. I wouldn't mind just. Yeah, maybe we'll save it for another night. You know, I know he just got off an airplane, so.
In amateur astronomy, we discuss what are called spousal permission units, which we're all in danger of running out of at any given moment. And the idea is each of us is given a certain allotment of time that we can abuse our spouse with our hobby. And you only have so many credits before your spouse starts asking you to pay up. And
oh no.
Yeah.
I'm gonna run out before I finish my thesis.
They renew. That's the nice thing.
Okay,
Anniversaries, Valentine's Day, we have ways of getting them back. Chocolate, nice dinners out, all of these things occasionally work. Know your spouse, know how to basically pay to get more spousal permission units.
I think I'm gonna owe my boyfriend, like, I don't know, a castle after the next few months.
Dissertations do that. It's okay.
Yeah, I'm already sort of with the number of hangouts and all this cool stuff that we've been doing. Definitely. As you see kids come in and just pass out beside me, I'm that boring right now.
Could you fall asleep with astronomy happening?
Well, that's great. Well, so there you go. There's Mars.
Yay!
I told you it wasn't anything impressive.
No, this is fantastic. I see the polar ice cap at the top.
That was my guess as well.
Yeah.
Sorry, it's not more exciting. I can slew over to the moon if you want.
And have you still got Jupiter? Yeah, let's do the moon. Let's just, the moon is always a crowd pleaser.
All right.
And have you got Jupiter there too?
Jupiter is on the other side of my house at the moment.
Are you hand tracking?
I am hand tracking. My mount doesn't do very well.
So there's Stuart.
Wow.
Stuart was just got off an airplane and he threatened to set up his telescope, but
Hi, Stuart.
I think he's we're not going to push him tonight because he's got to go and set up all his gear, and then there's always his Wi-Fi not working and his telescope moving and all that. So yeah, I don't know. We'll save that for another night.
That's fine. I got the Wi-Fi problem fixed though.
Oh, do you? Okay, great. Yeah. I really like the views from Stuart's telescope though. It's really nice. Great planetary stuff. Did you catch some of the earlier stuff that we're looking at, Stuart?
No, I honestly just got home.
Oh, okay. Yeah. Hopefully we'll get a chance to see it. We just had some beautiful views of the Rosette Nebula. Just gorgeous.
Cool.
The best views we've had. I think the best view we've had in all of these star parties so far. That was just phenomenal, Gary.
Well, there's the process.
Can you bring it back up? Yeah. Here's, if you could see, Stuart.
Man.
There's the view right there.
Oh wow, that's amazing.
Yeah, and that's the green one. He did a red one as well. But great. So here we go. So we get to. So Mark has got a view of the pretty much almost full moon now. And is hand tracking, which
That's
is
insane.
Which is crazy.
I had to do that once for public night on our 10-inch telescope, and so I picked Saturn because if people didn't say "ooh," then I knew that it was like out of line.
Yeah.
Is that a picture? Yeah.
Yeah.
Yeah. I just see black, and then you move it back.
Oh yeah, I think I see it. No.
Is that the Emperor's New Clothes test?
Yeah.
Kids will always tell you, I don't see anything. They will tell you the truth, but adults will be like, I see it.
And so is that Copernicus over on the right-hand side, that big crater that's... Oh,
I just zoomed in. Sorry, I'll zoom back.
That's all right. All right. Yeah, I think it's... Unless you can actually hand-guide it up along the top where, the Terminator is, where you can actually see the craters, and then zoom that in.
Yeah.
That's sort of the best view of all. A little there. Okay, good. Now don't move it. Hold it close, carefully.
Yeah, easier said than
Fraser,
done.
you are such a taskmaster.
I know, I'm the worst. That is awesome. That is beautiful, though. Oh, I love the view of the moon, especially.
Yeah.
I mean, it's such a terrible time to view the moon right now because it's almost a full moon, so you really want to get that, quarter moon.
It's always a good time to observe the moon in Moon Mappers on Cosmic Quest.
Is it always moon mapping time?
Yes.
Oh, phenomenal. And so what's your setup, Mark?
It's just a small little Meade ETX 90. So very basic telescope. It's just got a little go-to mount on it. I think it was about $400 or $500. So I'm not into any of these crazy mounts yet. You guys were talking about the spousal points earlier. I haven't earned enough spousal points to justify a good mount.
Yeah, and for
really addicting.
Yeah, and we've talked about that in the past. That really, it comes down to the mount. That in many cases you can see, the big difference. And you can see when Roy has his telescope going, he's got a bit of a bigger telescope, but he's got just this rock solid mount that just boom puts whatever he's viewing in right in the sky. Same with Stuart's mount as well. Really nice mount. And so with a lot of the moon and the planetary stuff that they do, you get a really steady view. And you can see with this, Mark is hand guiding it around to keep it in the field of view. So
yeah,
still,
if I just leave it, you can just see the moon just move across the screen. This is me not touching anything, so you can just see it gradually move.
You're watching the Earth move, people.
Yeah,
rotate.
The moon isn't moving as much as it's about the Earth rotating, but yeah.
You're hand guiding it pretty well though for that kind of magnification.
Yeah.
Well, thank you.
A lot of practice. Yeah, no, but I mean that's a great first telescope. I mean, this is what I think is really important for people to see. I mean, if you want to be able to get really fast images of really faint nebula from the light polluted Los Angeles skies, then what Gary's got is going to set you back. But if you want to get some just beautiful views of the moon, you want to see Saturn, you want to see Mars, Jupiter, some of the brighter deep sky objects, a $300-400 telescope is really all you need, and you're set. And so this is phenomenal. I mean, and it's also really good seeing where you're at, Mark. Like I'm not seeing a lot of atmospheric turbulence in it.
Yeah, it's very clear and crisp out tonight. And I'm sitting outside with my laptop, just so you all know I don't have anything fancy hooked up where a lot of these people have their control computers inside in a nice heated area.
Yeah.
You're doing old school.
Here, I'll switch to my webcam so you can see me in my silly hat.
Where are you located?
Just outside of Chicago.
Oh, that's not a silly hat. That is a survival hat.
Love the hat.
And a nice big winter beard.
Yeah, it keeps my face warm.
Yeah.
So we'll go back to something entertaining.
That's phenomenal.
I should point out, in addition to what you were saying before, Fraser, about getting your own telescope, you can also go to your friendly local observatory or amateur astronomy group if they have star parties, because then you don't have to do any setup of your own. You can just show up and people will show you pretty things. And it's a great way to spend an evening.
Yeah, I always recommend, if you want to see what it's like to look through a telescope, is to just seek out your local astronomy club, and they'll be glad to let you. They'll do open observing sessions, and in fact, Pamela, you're going to be doing one in San Francisco in March, right?
That's just a meetup.
A meetup.
Yeah.
But they do but they do observing, right? The San Francisco.
They do observing. So on February 26th, which is almost March, I'm going to be in San Francisco for the New Suborbital Commercial Space Conference. I think I got all the right syllables in there. And the day before the conference begins, I'm going to do a meetup at the SETI Institute. So if you want to learn more about that, you can go to meetup.com. And we're looking to get amateur astronomers in the area together to just talk science. But right now is actually the time to start thinking about summer vacations and summer star parties. There's a great star party each year at Big Bend, up at Yellowstone, at Flagstaff. There's all of these geologically beautiful places to go to that also have very dark skies, and then have these gatherings of hundreds of people sometimes, and you get the chance to do things like climb ladders and look through 30-inch Dobsonian telescopes that have 16-inch telescopes as the finding scopes, and they're insane and awesome telescopes, and anyone can just go pay your registration fee, camp out, and enjoy amazing skies.
Phenomenal. All right, well, I think at this point we're probably going to need to wrap it up. If anybody has any last questions, you can drop them into the comments. Thanks for everybody who watched us tonight, and thanks for all of the participants and for jumping in. Thanks for Mark for showing us this beautiful view of the moon in the end. Can you can you zoom out again?
Sure.
And we'll just get the whole moon. Yeah, look at
That's
that.
beautiful.
Gorgeous. Before you go, Fraser.
Yeah.
The one picture I've got up where there was some talking about what true color is, and that's taken in. If you could see the color, that's the color you would see. That's taken just through red, green, and blue filters.
Awesome.
Wow.
I want a shirt that glows.
That's beautiful.
Yeah.
All right. Well, amazing. Again, what a wonderful night. We were highlighted with the Rosette Nebula. We ended up getting 8 people participating and views from 3 telescopes, including this beautiful view of the moon to wrap it up. So thanks again. Thanks to Peter and thanks to Mark and thanks especially to Gary for running the show tonight, and thanks to all the color commentary as well. We've got Nicole and Pamela and Roy and Stuart. So thanks to everybody who joined us, and we will see you guys again at some completely random moment with absolutely no notice. So
we're honest.
Yeah. You get no warning. We just do this when we do it. All right. We'll see you guys all later. Thanks a lot.
All right, guys.
Thanks, guys.
Thanks, everybody.
Bye.
Bye.